Okay, so we're going to learn how to draw or graph quadratic functions. Quadratic functions look like this. They're also called a parabola, right there. And the thing about the parabola is they're always U-shaped, they're curved all the way through, and they're symmetrical on both sides. So if you don't get that, you know you've made a mistake. It's a mirror image on both sides. The key thing is we always want to start with a vertex and work from there. And that's the lowest point, or in some cases, it's the highest point on the quadratic. Now, what is a quadratic? If you look at a function, you can always see that it's a quadratic because the highest exponent is a 2. The 2 means it's curved and it produces a parabola. So, there's two kinds of quadratic formulas. We're going to use the general form for the first lesson. The general form always has something like this. It's usually a trinomial, but it has the x squared, the x, and the constant. Now you might have one of these terms missing, but you have to have the x squared to begin with. It can't be in factored form, and it can't have brackets on the equation. So how do we do this? We always want to start with the vertex, and our starting point is this formula, x equals negative b over 2a. So we're going to take the second coefficient divided by 2 times the first one. And it always has a negative. So if I do that, I'm going to get, for this one, negative 6 over 2 times invisible 1. So negative 6 divided by 2 is 3, or negative 3. So to get the other part of the vertex, we need to find the y-coordinate. So we're going to take this negative 3 and we're going to plug it into the formula, or in this case, this one where we started. So we're going to get negative 6. So from here, we've got the x, we've got the y, our vertex. Okay, step 1 is finding the vertex. We found that. So I'm going to put this on the graph, negative 3, negative 6. So we've got the vertex. Now we've got to fill out the sides of the parabola, just like this one. And we're going to use something called over-up table. Now, usually a table of values, we always start from the origin and go x coordinate first, sideways first, then up and down. We're going to start at the vertex. Now, these two parts move the vertex from the origin down here. So we're going to use this part for the over-up table, just the 1x squared. Now the over every time is 1, 2, 3. Chances are 4 and 5 won't fit on the graph, but we can put them on just to show you. Now over is always just 1, 2, 3, 4, 5. The up is taking this first term. So the up is going to be x squared. So 1 squared is 1, 2 squared. As you can see, 4 and 5 are just too big. They won't fit on the graph. So we always start at the vertex. I'm going to start here. I'm going to go over 1 unit, up 1 unit. Over 1, up 1. But I have to do it both directions. So over 1, up 1. Notice that we're starting to get the bottom of the parabola. So we go to the next one, 2 and 4. So I'm going to go over 2. Always go back to the vertex. From the vertex, over 2, up 4. And we do it in both directions. We go to the next one, over 3, up 9. Back to the vertex, always starting from the vertex. Over 3, over 3. Now you can see the parabola. So when I draw this, and I don't even need this many points, but always kind of curve it up, going through the points. 16 does not fit on the graph. So that means I should not cross another line after this dot. And keep in mind, it's not a V. I want to see a nice curve on the bottom. So it's U-shaped when it's done. Even if it's really skinny, make a curve in there. show that it's not a point. So let's try this one. We're going to go back to the beginning. X equals negative b over 2a. And 2a, 2 times 2. Now we've got a double negative, so it's going to become positive. 4 divided by 4 equals 1. That's half my vertex. What's the next step? We need to find the y-coordinate. So I'm going to plug this in, and we get 0. So we've got our vertex. I'm going to put it on the graph, 1, 0. Now I have to start filling out the sides. So over, up, over, and chances are we won't need 3, 4, 5. They're too big, but let's fill out the table, see how big they are. So the up, we're always taking the first term. So instead of just squaring it, we have to do 2 times x squared. 2 times 1 squared is 2. 2 times 2 squared is 8. 2 times 3 squared, 18. And we can see that's already off the graph. We're not going to be able to fit it. And again, the last 3 points won't fit on the graph. If this is a fraction, if it's 1 over 2, 1 over 4, then we might need these points. But we definitely can't fit these ones on. So, always go back to the vertex. We're going to start at the vertex, and we're going to go over 1, up 2. Over 1, up 2. Always do both directions, over 1, up 2. Now we can see where it's going. The next point, we've got over 2, up 8. Back to the vertex, always the vertex, over 2, up 8 in both directions. And this one doesn't fit on the graph, so I'm not actually going to hit that next line. Make it curve. And so one thing I want to see in this, I do not want to see a straight line off to the side. Once you hit that point, it keeps curving. The only time it goes straight is if it's pointing straight upwards or downwards. There's always a curve at the bottom, curving up to the side. No straight lines, no sudden change of direction. It can't hit the point and go outwards. Okay, so that's what it looks like. Just a quick recap. We always start with the x equals negative b over 2a. We find the x coordinate. We take that, we plug it in to find the y coordinate. Once we have the vertex, we move over to over-up table. Okay, so let's go over some of the vocabulary. Some we've already covered. The vertex, we're using this formula, is always the lowest or the highest point on the parabola. Axis of symmetry is an invisible mirror that goes right through the middle. It always goes through the through the vertex, and it's represented by the x coordinate of the vertex. So if we go back to the ones we've already done, the vertex goes through -3, -6. So the vertex is a line, x equals -3. Over here, the vertex goes through 1, 0. So the vertex, or the axis of symmetry, is a line at x equals 1. Just remember, it should be symmetrical on both sides. Now, intercepts for the y-intercept is pretty easy. We're making everything, all the x's equal to 0. And if we do that, all of this becomes 0, and just the constant at the end, that is the y-intercept. So it's a quick way to check. Let's go back to our original 2. If we look at this, 3 is a constant. 3 is the y-intercept. 2 is the constant. 2 is the y-intercept. It's a good way to check that you've done your work properly. And for the x-intercepts, we're making y equal to 0. It's where we cross the y-axis. Now, the thing about the x-intercepts, we're going to focus on them in the next chapter, but you can see that it could be 2 intercepts, it could be 1 if it hits and bounce off it, or in some cases there are no x-intercepts. Again, we'll focus on that in the next chapter. Okay, so one thing we want to be able to look at is looking at each one, what do we expect to find? Now, the A is the first coefficient, the leading coefficient for each quadratic. And it tells us some information. So if there's just y equals x squared, it will look like this one here. It's not too narrow, but it goes up and it curves pretty quickly. The bigger the number that's in front, the leading coefficient, the skinnier it gets. If it gets bigger than 4, it'll get skinnier and skinnier. Now, what happens if it gets smaller? Let's say 1/2 x squared. This would just get wider. It would go out even more. So the bigger the number, the skinnier it gets. And that just means it's going up faster and faster. You're multiplying by a bigger number. If you have a negative, it just means it's going to point downwards, like that. So positive is facing up, negative is facing down. The bigger the leading coefficient, the skinnier it gets. So let's go through these ones. We're just going to look at these formulas and just say, what do we expect to find? What is the y-intercept? Which way does it face, up or down? And what is the vertex? So y-intercept, we're making all the x's 0, and we're left with a +2. So A will go through the point 0, 2. It faces, it's a negative, so this is going to face down. And the vertex, we're going to go back to our formula. It's going to be -12, 2 times -2. To find the y-coordinate, I'm going to plug 3 into my equation. So in this case, the vertex will be 3, 20. That's what we're going to do for each one. Try it out. Pause the video, see which ones you can do, and then check your answers afterwards. So in case you got stuck on any of these, just remember if there's a missing term, there's just an invisible 0. So this one had a 0x, which we need to use in the vertex formula. 0 divided by 2 times 3 is still 0. This one had a missing term at the end, so I just put +0 at the end, which means the y-intercept is 0, 0. So if there's something missing, just fill in a 0 as a placeholder. So what I want you to do is pause the video. Try these two out, see if you can graph them, and then check your answer. So check out your work. Hopefully you had something like this. There's no straight lines, it's curving through the vertex. It's curving. It'll never get straight until it's pointing straight down, or in this case, up. Always curving towards the vertical.